We talked a little bit the other day about the fact that if you're going to go out and collect a set of data, you just don't go ask whoever. You have to have a legitimate method to go collect that data. When my pre-calc students do their projects, they come looking for specific ones of you. They don't just pick whoever they run into. Okay, and so there's actually 5 sampling methods. This is the last question on your journal, by the way. What are the 5 sampling methods and describe them? So somewhere you need this in your notes. The method we actually don't want you to use is the first one, although sometimes the situation makes you do what's called convenience sampling. You have no other choice. You've got to just ask whoever is available. You don't have the ability to collect the data in any other way. So if you're doing convenience sampling, hopefully it's more than just standing on the street corner and asking whoever walks by. You would hopefully position yourself at some place to conduct your survey that might help you get a wide range of people. So you need to collect data at different locations so you get the opinions of different people from different. If you're doing people, they have to be different income levels. You don't want to just pick whoever because you're not going to guarantee you're representing their whole population. So convenience, while sometimes necessary, we prefer not to use it. Random works well, but it's kind of hard if you got a big population you're trying to choose people from. Because in random, everybody has to have the same chance of being selected. So you therefore have to know who all the possibilities are that you can pick from. So if you're trying to do the city of Seneca, how would you randomly select people out of the city of Seneca? If you knew everybody's name, you would have to throw everybody's name in a hat. Well, how on earth do they come up with everybody's name if they're trying to do a city or something? Usually, through, a lot of times it's voter records, the registered voters. They'll get the list of registered voters, and then they randomly select from the list of registered voters. So, here at school, when we're only a population of a little over 200, random's pretty easy. I had some pre-calc people who literally this year assigned every one of you a number. They had the list of names. They assigned you all a number, and they let their calculators pick random numbers. It will do that. And then they just interviewed whoever the random numbered people it picked. That worked. And, if it's not a very big group at all, you can literally put everybody's name on a piece of paper, throw them in a hat, and draw them out. That's random. Okay. Systematic is good if you have a list to choose from. And when I say select every case person, I mean select every 5th person on the list. A lot of times, back when you could guarantee that everybody was listed in the phone book, they would take the phone book and call every 10th person in the phone book. Just start calling every 10th person and interviewing them. Whoever they were, didn't matter, they didn't know. Here at school, we got a list of your names, and we can pick every 7th student and interview them. The systematic is actually a pretty easy one. The last 2 are easily confused, because you'll notice they both start with the words, divide the population into groups. So they both split the population up. It's how you choose from those groups that matters. If it's stratified, you randomly select a few people from each different group. And the easy one for that one is here at school, you guys are divided into freshmen, sophomores, juniors, and seniors. So it's really easy to say, I'm going to randomly select 10 freshmen, 10 sophomores, 10 juniors, 10 seniors. Randomly select from every group. You know you've got people from each class. So stratified breaks into groups. It takes some out of every group. Okay, cluster, a lot of people will go, well, why would anybody do cluster? Cluster divides you into groups. Then you randomly select a few groups, not individuals, but you select the whole groups. And the key thing is you do everybody in that group. Like here at school, you all have an assigned seminar. We could randomly select 4 seminars and go interview everybody. Everybody in those 4 seminars has to do the 3D PAR. So the key thing that gives away cluster is everybody in the group's going to do it. A better example of this out in the real world, if you have a large number of groups, And my example would be, how many Starbucks stores do you think there are? Starbucks coffee. Thousands. Tons of them. Okay, if they wanted to do a survey with customers on how satisfied are they with their products or whatever, do you really think they want to interview people at every single location? That'd be horrible, trying to figure out. So instead, they would randomly pick a few of their stores, and they would do all the customers who come in those few stores. They wouldn't want to try to do a few out of every store. It would be too hard to keep track of. So cluster, big thing. If it says you're going to do everybody in the group, it's cluster. So you're going to, on today's assignment, you're going to see, you're going to hit a page front and back that says measures of variation, and then the page after that says statistical sampling. And so that's part of your homework, but all you have to do, in fact, we'll do the first couple here, is number 1 says a teacher selects every 5th student in the class for a test. Which method is it? Systematic. Pick every 5th person. Okay, second one, a teacher writes the names of each student on a card, shuffles the cards, and then draws 5 names. Random, yeah. They all had equal chance. Okay. Number 3, a teacher surveys all students from each of 12 randomly selected classes. So they picked 12 classes and they did everybody in those 12 classes. The key thing is the word all should scream at you. Get all students in the class, that's cluster. So you just have to go through there, read those, say which method it is. The last 4 questions at the bottom, I just want you to see, I just want to make you think. It asks you to describe what sampling error is occurring. So what's wrong with how they're doing this study is what I'm asking you. 13 says a car manufacturer collects data on waist size of the drivers. They need to know how big to make the seatbelt or how small. And they collect this data by selecting a random sample of drivers and asking them to report their waist size. So they randomly select a bunch of different drivers and say, tell me what your waist size is. Yeah. Are people going to always report their accurate waist size? Heck no. A, number 1, they're going to lie because they want it to sound smaller. Or B, they probably don't know. I mean, I would have, not necessarily particularly not all girls' clothes have an actual waist size. A lot of times girls don't know waist size. Guys' pants are always by waist size, so they've got a better idea. But, yeah, this is not a good way. You would go measure these people. If you want accurate data, they would need to measure all these people for themselves what the waist size was. You would not ask people to tell you. They aren't going to give you correct information all the time. So that's what I'm looking for now. Otherwise, yes, you're doing the measures of variation page. Is the big thing today.